He was an assistant professor of math education and science education there. And his research focuses on teachers' problems, technology, and thinking. He was the recipient of two social science research grants in Canada. Very prestigious grants to conduct research in math education there. And he is co-editor of a new volume on collection of articles and papers about probabilistic thinking from a historical, philosophical, and cognitive perspective. So he's going to talk to us today about relative comparisons, comparative literature.
Thank you, Louis. Thank you for all of you coming out this afternoon. I figured out the key to get good numbers at a colloquium talk is to come to a place where there's a very large population, so then everybody just fills out the room. I will talk to you about that today. That's what things are like right now, where I'm from. So it's a little bit different than what I noticed when I was walking around. So Louis said, hey, come on down. And when I realized that that could be the opportunity, I jumped on it. So I was going to maybe try my sandals and wear them today, but I decided against it. So this was the abstract. It's too small to read. Please don't spend time on it. We're going to go through it, and we're going to talk about some key points. We're going to talk about relative likelihood comparisons. We'll get to that. This is actually beginning with some very seminal research in the field of psychology. We have two famous psychologists, Amos Tversky and Daniel Kahneman. You'll hear me talk about them a lot today. Then we're going to venture over and talk about what's happening in this area of mathematics education, because there's alternative theories and frameworks and models. And then I want to hop back because there was this notion of major developments in the field of cognitive psychology, which were inexplicably ignored by people in math education. So we'll venture there and end with a little bit of conversation about logical fallacies. So we begin with an homage. I want you to read the question, and I want you to think about your answer to that question. And I would also like you to think about how a prospective teacher of mathematics might answer that question. So you're presented with two particular answer keys to a multiple choice quiz. I found out just recently there's been some technology that's being developed trying to get rid of the Scantron, where you can use your iPhone and scan in the Scantrons. But why would I ask you to take a look at that? Amos Tversky has passed away. He was part of the dynamic team, the seminal psychologist, Amos Tversky and Daniel Kahneman. In 2011, he wrote a book called Thinking Fast and Slow, and in it he was asked about why their original heuristics and biases program was so successful. And what was interesting to me was the part where he talks about we almost always included in our articles the full text of the questions we had asked ourselves and our respondents. And this is part of the appeal to it, which is why we begin with that particular question. Including the question in the research articles was a unique way for people not to be able to hide, essentially. You're reading it, you might fall prey to the heuristic or the bias that's part of that. So that's why we have to begin with that question. So, like I mentioned, psychology then, we're going to talk about what happened in the field of mathematics education. We'll talk about psychology now, and then we'll get back to mathematics education. There's a gentleman who wrote a book recently, and he is the next in a long string of individuals who are popularizing psychology. And he wrote this book called You Are Not So Smart. And in it he goes through a number of heuristics, biases, and fallacies. I somewhat take exception to the title, You Are Not So Smart, because this is a defining difference between two camps of heuristics and biases research. We have the Kahneman and Tversky camp on one side, and we have the Gerd-Geibrinzer group on the other side. And the notion of whether heuristics are, I don't want to say good or bad, but whether they lead to problems or whether you can have accurate heuristics is a defining difference between the two camps. Kahneman does address this point, and this is something that I wanted to make sure that we're aware of when we see the title for the book. The focus on error does not denigrate human intelligence any more than attention to diseases in medical texts denies good health. The Gerd-Geibrinzer camp has actually largely been ignored by the mathematics education community. We are trying to address that, and that's why I have shameless self-promotion up there for the probabilistic thinking. But Lewis was nice enough to mention that book that's coming out, so it's our promotion with it as well. So let's talk a little bit about what I mean by heuristics, biases, and fallacies. So Kahneman in his book, and again, Kahneman's book is also an attempt to popularize a large body of research, and he talks about it in giving people terminology so that they can have a conversation around the water cooler. So we see that the heuristic is a procedure that helps you find adequate, although often imperfect, answers to different questions. The popularizer, David McCraney, is something that we can use here for what we're going to be talking about when I talk about heuristics, biases, and fallacies. So heuristics, in a sense, are these mental shortcuts to solve common problems. These will lead to predictable patterns. These are the biases that will come out. And the fallacies we'll get to in the last part as well. So, this began with a question. Actually, it began earlier with Cohen and Hansel in '58, but the 70s, the late 60s and the early 70s is considered sort of the beginnings of the heuristics and biases program. Again, think about your response to the question. Think about how someone else might answer this question. We have two sequences of boys and girls. You'll notice some differences between there. This was the first of two questions that was presented to people. The second, and I am pressing the slide, there is a difference between this slide and the next one. This was the second question. So this one stayed the same. One more time. The first one had boy, girl, and then 4 boys compared to this here. And the second question was boy, 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 girl, 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 compared to this sequence there. So again, you're thinking of your response, you're thinking of someone else's response. A number of very, very influential papers come out of these questions. The law of small numbers, we know the law of large numbers as a mathematical property phenomenon. The law of small numbers is considered a psychological phenomenon. So this was something that they investigated in the early 70s, and then this one here, the subjective probability, this is what we're going to focus our attention on. The notion of representativeness. I have a star there because it's very important, and we might get to this or we might talk about it a little bit later. There was a lovely little comment that was dropped at the bottom of this article, which now looking back, I think may have absolved them of a lot of controversy that may have surrounded. It should be evident that this terminology is non-committal with respect to any philosophical view of probability. And anybody familiar with the Bayesians and the frequentists can see why this might be something very important to put down at the bottom of a paper like this. If you are looking for the article on this heuristics and biases program, that is the article in the journal Science from 1974. But if you're looking for a more comprehensive overview of it, a book was put together here in 1982, reprinting, commenting on all the articles. So we're going to talk first about the representativeness heuristic. There were 3 that were addressed in the original heuristics and biases program in the article from 72 and 74, but I'm going to focus with you, and we don't have time to get into the availability heuristic or the anchoring and adjustment effect, but they're fascinating on their own if you're interested in those. I want to talk to you today about the representativeness heuristic. So instead of calculating or determining the probability of the event, there is this judgment, and the judgment is based upon 2 components that we're going to talk about. We're talking about the essential properties to its parent population, and we need a reflection of how this is generated. These have particular names to them, which we'll get to in a second. The notion of representativeness they talk about in 1972 is best explicated with examples. So we're going to look at one. We've looked at a bunch of them already. So we have birth sequences of boys and girls that are considered equally likely to occur. This, again, the non-committal stance to an interpretation of probability, but they don't appear equally representative. So we go back to our questions. If you know about the representative heuristic, has it influenced your response to the question, or has it influenced your response to how someone else might answer that question? These were the two that we were talking about. So we had that one there, and that one there. Yes?
So are we supposed to ignore knowledge that boys are in fact a little bit more likely than girls?
We'll get to that. There's lots of things that we need to address with this, for sure. You're right, the population is not 50-50. And we'll get to the notion of a contextualized sequence versus what I've tried to call a platonic sequence when we get through back into the math education component.
Or it takes place in a society where boys are considered more valuable than girls, and bad things happen to baby girls.
Yes.
That's another thing that fuzzes up the question.
Absolutely, and you're now starting to see reasons why people can get drawn into this particular area, because these are some of just many examples, and we'll try and parse that out with this. So, when they present the research, the majority of individuals, the vast majority of individuals are choosing boy, girl, boy, 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 boy as least likely. And in terms of the representativeness heuristic, what had happened is they are declaring that the population ratio that is existing in the larger population is now expected in the small sample that you take. So we have the notion of local representativeness, the law of small numbers playing in. But the determinant of representative here was given the name similarity of sample to population. To control for that with the other question, they say, of course, we'll make these have the same ratio of girls to boys. So we have a 1-to-1 ratio, but you can see that this one here might not be as representative because it goes a boy, a boy, a boy, and then flips over to a girl and a girl and a girl. So it doesn't appear random, or this perception of randomness was causing individuals to think that it is less likely than the other sequence they are presenting, denoted the name reflection of randomness. So, the field of mathematics education, talking about probability, the teaching and learning of probability, teachers' probabilistic knowledge, the terms are somewhat used with impunity in this particular area, so we'll get to that in a second. But it's used by a large number of people in the field of mathematics education. So this seminal research that's coming out of the field of psychology is considered sort of the ground floor of what's happening for those investigating probability. I am only going to be able to get to a few of these with you today. I'm going to talk to you a little bit about the person who brought it over. We're going to talk about one of the major developments to the task, and then we'll get into what's happening a little bit later down here. The rest of them, again, as interesting, if not more, but in the interest of time, we'll be able to get to them. Quickly, on the side of this, there are people who are not just investigating the comparison, this relative likelihood. We have people who are focusing their research specifically on perceptions of randomness. So there's a large group of people around this time that are looking for it in psychology, and there's a larger group looking at math education. You all know, because you're in a department of mathematics and statistics, about the folklore associated with the mathematician. And he presents this notion to the students. He is willing to walk outside of the room. One person is going to write a string of heads and tails on the board, and the other person is going to flip a coin, and they are going to write the resulting string of heads and tails on the board. The mathematician then walks back into the room, and like that, is able to determine which one is made up and which one is real. How many people are familiar with this story? Oh, I'm surprised. Does anybody have any examples or reasons why they think, there's no hesitation. The individual walks into the room and goes, this one is made up, and this one is not made up.
What your central theme of your talk is, that what some students would consider random really isn't random. Because because runs of the same head or tail are more common than people would be willing to write down.
Yes, can you take it a step further? Can you tell me a little bit about the runs, or maybe the length of the runs that people might expect versus what could really happen?
That if you count them up, I mean, you will get to get the number of runs that are one more is like, what, half of the ones that are one length. So the runs of length n occur twice as often as the ones that are n plus 1, something like that.
You're at the heart of it.
Heuristically speaking, of course.
Excellent. Now, the mathematician is able to walk into the room and go, this is the one that you made up. And the reason why is because the length of the runs is too short. So if you were to flip a coin a certain number of times, a large number of times, you can expect to get runs of 7 or 8, and it's not an anomaly. But when the person is in the room and they're writing down the heads and the tails, when they get to the notion of 3 heads in a row, they think, okay, I now need to change this over to a tail, or else it's not going to appear random. So we'll get to this as well. The key with this that they're talking to, and this is the folklore behind the mathematician, we need very frequent switches from head to tail or tail to head, and short runs. So this is something that's happening in parallel to the research that's happening on relative likelihood comparisons. So issues have already been brought up with the task, and those do not go away. You can see how the question was presented by the psychologist earlier on. You're going to see that it changes here. So issues with the task still persist. They will always persist, but there's been developments to it. So one of the things that happens when Shaughnessy brings over this research is he tries to address the inferential issues. It was a forced response in the psychology research. You had to pick one of those two sequences. So he makes some changes. He asks for a request for reasoning. Could you please justify your response? And puts another option in there and says both of these sequences are equally likely to occur. These are two major task elements that are continued throughout all subsequent research. Then, more sequences come in. So Cliff Knold and his group started working on this as well, and he actually made a distinction between least likely, most likely, and this now has led to the ubiquitous outcome approach, which is seen in most likely versions of the task, and we won't have time to go in it to talk about it today as well. But the other key part, other than the outcome approach, is the framework. This framework now, these developments that have occurred, is what's getting adopted to it. So what does it look like? Well, we see 4 or more sequences that are presented. We see an equally likely option, and we see response justification. This is what the task now looks like. So, what are the people in math education doing beyond playing around with the task or the framework? Well, this gentleman at UC Berkeley, Dor Abramson, is doing, or was doing, some very interesting work, and he had this notion called inadvertent metonymy. This notion of inadvertent metonymy actually has a lot of parallels to what we'll talk about when we get back into the field of cognitive psychology in a minute. But he starts to make a different argument and says, whoa, hold on a second. We need to take a look at this. So if individuals are using something different, if they're making a substitution, and in other words, instead of seeing head on the first flip, head on the second flip, head on the third flip, and tail on the fourth flip, if it's seen as 3 heads and 1 tail, that's a different question, because now we do know that 3 heads and 1 tail is going to be more likely than, for example, 4 heads and no tails. So what he starts to talk about is, if this is the case, then we need to revisit what people are doing. This is the beginning of a look beyond the normatively incorrect response. So yes, you can look at the response and say one sequence is less likely than the other. This is incorrect. But we can continue with this a little bit and say, well, if this is where we are, let's swim in this end of the pool for a minute and see what happens. At a similar time, I started playing around with the same notion, but instead of looking at the ratio of heads to tails, I started looking at how people were describing their responses. So instead of looking at the ratio, I started to take the sample space And I just treated it as elements of a set. So when you see the sample space in your textbook, you know what it looks like. It's this lovely diagram like this, and it's organized according to the number of heads and tails, and then one less head and one more tail, and it goes along in that direction. Well, I started looking at different organizations of the sample space. People were saying, well, this number of runs is considered less likely. So I started organizing the response and analyzing it according to a reorganization of all of the coin flips in the sample space, and a number of different things emerged. The issue with it, which was brought up earlier, is that we've seen 40-odd years of research into relative likelihood comparisons, and it was just coins and babies. So you either talked about flips of the coin or the birth of boys and girls. So after we started playing around with some of the examples, we started looking for different contexts. And you've probably also heard, given the Department of Math and Statistics, about the lottery ticket situation. We have one individual who buys a lottery ticket, and the numbers are 1, 2, 3, 4, 5, 6. And another lottery ticket is presented, which may have a different set of numbers, and the question that is posed to individuals is, which lottery ticket has a better chance of winning the lottery? And people will say,
The wrong thing.
the wrong thing. Now, what do you mean by the wrong thing?
They'll say that in order to win, it has to look more random.
Has anybody caught on to those numbers that are up there? Because when I said 1, 2, 3, 4, 5, 6 versus some other set of numbers, sorry?
From Lost.
It's from Lost. What do you mean it's from Lost?
It's the winning lottery ticket numbers from Lost.
The winning lottery ticket numbers from the TV show Lost are 4, 8, 15, 16, 23, and 42. So you may have been sitting there going, well, 1, 2, 3, 4, 5, 6 versus this here. But if I tell you that those are the show or the numbers from the TV show Lost, that might change things a little bit again. So you can see it's a little murky. The waters are a little muddy, and it's not so cut and dry, which is part of the reason why I like this area. So we started looking at some other ones. We have the answer key to a true-false test. And so you'll have some people that are thinking back, hopefully, to the last true-false test that you took. And when you got to the third false in a row, you went back and started to question yourself a little bit, going, well, wait a minute. It doesn't really matter what my response is. There's no way that they're going to put 3 of those in a row for a 5-question test, and now you're getting into your head a little bit here in your answering of that. This one here was one of my favorites, favorite in the sense that people were very interested in this story. There were severed feet that were washing up on the shores in British Columbia in 2007 and 2008, and what happened was the first 5 were left feet. And the stories started going crazy. People are trying to explain how it is possible that you are going to have a left foot show up, a left foot. People are going, well, where's the right foot? Where are the right feet? And then we actually had this instance here from the 4th left foot to the 5th left foot was quite interesting because people are now starting to say, well, there's no way that the chances of a left foot and a right foot are the same because we've had this many left feet show up. And there were some very graphic and disturbing explanations as for why you would have all of these left feet showing up. The headlines would have things like the fetish of the person who's cutting off the feet is with the left foot. There were all these crazy explanations associated with it.
Oh, wait, wouldn't that be the right foot? Because that was the one they were keeping. Going the way the...
No comment. So what I wanted to do is I wanted to start looking into these contextualized sequences, but when I looked through all of the research that was happening in math education and all of the research on psychology from then as opposed to now, there wasn't really a sufficient framework. So I went back and I started looking again at the field of cognitive psychology. So if any of this is resonating with you or you're interested in it, these are sort of the main pieces that you could take a look at. Again, the book from '82 from Kahanman, Slovik, and Versky. The developments have been nicely summarized. They've been talked about with Kolovich, Griffin, and Kahanman. And again, this popularization here with Kahanman, thinking fast and slow. You know, put it in your headphones. You can listen to the book now. It's quite interesting. Again, the Geibrenzer camp is still having issue with a lot of what's going on. You may have been familiar with the book Blink with Malcolm Gladwell. There's lots of interesting conversation there. There's also a very interesting conversation about Daniel Kahanman talking about Blink and what's happening with the differences there. Again, unfortunately, not enough time to get into the differences between the camps. What I want to focus on here with you was not only was the whole general heuristics and biases program revisited, the representativeness heuristic has been revisited. And I think it's quite interesting. So that's the other major compilation of all the developments of the heuristics and biases program. So before we get into the revisitation of the representativeness heuristic, let's take a look at the broader picture that's going on. And what I'm going to talk about is housed within this notion of dual process theory. And this is where the title from the book comes from, Thinking Fast and Slow. You have your system 1 and your system 2, and we're not going to get into a lot of the details, but the system 1 is very fast, it's intuitive, it's quick. System 2 is sort of very more deliberate, and you can override, in certain instances, system 1, and there's very, very famous examples that will demonstrate system 1 versus system 2. Again, another lovely area to spend lots of time on. So let's get more specific. They were able to, Kahanman and Frederick were able to genericize this notion of heuristics and biases. It wasn't for specific examples. We did not need to talk about coin flips, for example. There were lots of other instances where this applied. So they went through and they came up with something that is known as attribute substitution. I used this very example when I went for my job. And I kind of set things up a little bit, but it was quite fulfilling for me to be able to, during my job interview, put up this very question that I know some people were sitting there going, okay, is this person viable for our position here? Well, the talk is going okay, hopefully. and then I was able to throw this up here, and it was quite a nice moment for me. But the notion of attribute substitution, you're going to have a target attribute and you're going to have heuristic attributes. And the substitution of a heuristic attribute for a target attribute is the core of this. So you're answering an easier question. Instead of going, okay, how likely is it that this candidate could be tenured, you're going to reduce that with a simpler question. So this is where things get a little murky because heuristic now essentially has two meanings. We have the cognitive process sense of the word heuristic, but we also have heuristic as a descriptor. So keep that in mind as we continue on. But what we're going to see is that there will be a target attribute that is expecting to be judged, and instead of judging that target attribute, other heuristic attributes are going to be used to make that judgment. And that's where we come back to this. So I utilize the attribute substitution to analyze some of the responses from prospective math teachers when I gave them this question. So smaller group, we were just playing around, we were looking at, so 2 different classes, and I had 48 of the 59 people choose the second answer key to be the least likely answer key. So those people said this one here is least likely to be the answer key. Again, the design, as was the case in the previous research, is to present sequences that are considered equally likely, but are not necessarily equally representative. And some very interesting conversation came out in their response justifications. Now, we know that the sample to population determinant of representativeness is something that's established. We saw that you're expecting a certain ratio of heads to tails for this, but now they're expecting that the ratio of answers for A, B, C, and D is preserved as well. So it's least likely because it only has C's and D's. Again, the local representativeness. There's too many in a row. You get inside your head, you're doing a 10-question multiple choice quiz, and you got 6 of them in a row. You start thinking and going back, going, okay, well, wait a minute. Now, that's not necessarily captured with these heuristic attributes, so some other ones started to come out. A number of people had this innate notion of what an answer key is, a prototypical answer key. If you closed your eyes right now, you could probably picture it. So Mary says, well, we're not going to have these in a row. They're usually mixed up upon each other and will occasionally be in a row. She has this notion of a prototypical answer key. Other people started getting back to their experiences with it. This, as a student, always made me confused. So the response to the question, there is a particular heuristic attribute that we're trying to deal with, and we're starting to see a particular target attribute, and we're seeing these heuristic attributes that are coming out. Someone started talking about, we'll get to it in a second, we see that some people are saying, well, wait a minute, the reason that this answer key would never look like this is because of the person who's making this test. The tendency of the test maker is why this is not going to be as likely. So we're seeing that, yes, we have these heuristic attributes that are part of the original heuristics and biases program, but a lot of other stuff started to come out. Doug is essentially saying, no, you can't catch on. Because if you catch on, then you're going to get all these right answers because you go, well, these 7 are going to be C. You don't even have to start reading the questions anymore. You just start filling in C all the time. And then the interesting notion was they started to just all get jumbled together. We saw test maker tendency, we saw pattern recognition, we saw all of them, the conspiracy theory associated with answer keys go something like a rhyming scheme. A teacher, so now we see that all of these heuristic attributes are at play when this person is answering this question. It would both corrupt, a little dramatic, but it would both corrupt the integrity of the test and play mind games with the student. So you can see that there is a lot going on here. Now, from these responses, I'm trying to make the argument that their judgment in this instance is mediated by a heuristic. And we see there's a whole bunch of different heuristic attributes that are being used. Some people are saying, well, the population ratio, no, it's got to be 25% for answer A, answer B, answer C, answer D. And we have other people going, it would corrupt the integrity of the test, and it would play mind games with the students. So when we move from the very specifics associated with the heuristics and biases then to the heuristics and biases now with this general notion of attribute substitution, we can entertain all these different responses. So the target attribute, and this is where things get a little bit difficult. The essence of attribute substitution, and this again is the essence of the original heuristics and biases program. Respondents are offering a reasonable answer to a question that they have not been asked. So this got my mind spinning a little bit, and I thought, okay, if it is possible that they are providing responses to a question that has not been asked, I started to think, well, okay, what are potential questions that they could be asking? Again, I had no idea of knowing that this is going to be the question that they were asking or not, and we'll get to another particular point to drill that home in a second. But if they were asking some or answering some version of which of the following answer keys have you least likely encountered, or for example, which of the following answer keys is least likely to be generated by someone making a test, I'm interpreting these normatively incorrect responses differently now. Again, I know that it's incorrect in terms of black and white, yes or no, but yeah, answer key 2 is not a prototypical answer key. You were less likely to encounter answer key 2 in your past experience. And yes, and you may be one of those individuals yourself who started writing a quiz and then had to rewrite answers A, B, C, and D because you realized that 7 C's in a row could corrupt the integrity of the test and play mind games with the students. And yeah, they could pick up on a pattern, right? So you look at this and go, could it be possible that Chernoff put 7 C's in a row to end this quiz? And then the value judgment placed on me, and the answer probably is yes, he would do that. So then you could just go through and pick C the rest of the way through and everything would be fine. So some difficulties here though. I'm confident in saying I'm not able to determine for sure the question that they have not been asked, but are answering. The other part that's the issue here, and this is something that comes from the notion of attribute substitution, there is no confusion on the part of the participant. They simply fail to notice that they are answering a different one. So this is something that I need to consider or take into consideration when I'm moving on with this. But what am I doing here? What am I trying to get a handle of? I'm essentially trying to get a better sense of, and you gentlemen were talking about it earlier, well, wait a minute, we have a lot of things to talk about here. There's lots of issues going on. And the question in most cases is the culprit here. So we're talking about some sort of legitimately reconstructed tasks, but the key part for me why I chose attribute substitution is from this here. The alternative view for the attribute substitution is that when you take a look at what's going on, you're getting a sense of their understanding of the question that they were asked. So that's what I'm trying to get in this particular instance. And again, and I know this is sort of a big comment to say because we all know that the counterintuitive nature of probability is well established, but if we look back to it again, yeah, that answer key was less random. So we need to take these things, appeared less random. We need to take these things into consideration when we say, well, maybe it's counterintuitive because we're looking at the dogmatic normatively correct, normatively incorrect. If we start playing around with what's happening with normatively incorrect responses, we can have a new conversation about the counterintuitive nature. So, what's happening right now? I moved back to the coins and the babies. I never expected to go back to coins and babies so quickly. So I tried it out with the answer key, and what that demonstrated for me was the attribute substitution model was something that I could continue with. So I went back and I gave sequences of coin flips. And something really interesting happened when I shone this on the research about the coin flip sequences. They are making comparisons about the likelihood, but not of the target attribute. They're comparing the likelihood of all the heuristic attributes. And they're doing a good job with it. They're providing reasonable responses. So instead of them looking at and assessing the target attribute, they compare the likelihood of the patterns they see, the perceptions of randomness, the number of alterations. So when they're talking about most likely and less likely, their comparison is of a number of heuristic attributes. So ultimately, with this attribute substitution model, and going back to Abrahamson's work and my work in 2008, 2009, I ultimately want to marry the two together so we can see what happens there. So, while I'm doing that, I thought, well, okay, let's try something different. Let's take a look at some logical fallacies that are popping up. And you know of the logical fallacy, the gambler's fallacy. That's where you're sitting at a slot machine and you're playing it, and you hear those conversations where a person puts it in again and again and again and again, and they're not going anywhere because it's about to pay off. Right? And so if they have to go get, a glass of water or to the washroom, you'll see it if you go into the casinos, you'll see a bunch of chairs, and the chairs are sitting like this. Because that person has been there for a while, they have to leave the situation, they're coming back, because this is about to pay off. Right? Head, and then 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 head. Tail is coming. Left foot, left foot, left foot, left foot. Come on, left foot again. Give me a break. There's got to be a right foot that's coming. Right? So the gambler's fallacy is very well established. So I went in with one of my graduate students, and we started revisiting logical fallacies and kind of using this now as a way to take a look at what are considered normatively incorrect responses to a bunch of tasks. And two interesting ones have come out just recently, and I'll touch on those before we get to the conclusion here. So we've seen the notion of the appeal to ignorance in some of the research that we're talking about. Again, not enough time to get into it. I want to talk to you about the fallacy of composition. So we've seen the heuristics and biases program then. We've seen some math education theories. We've seen the heuristics and biases program now, and we're starting to see some evidence that the fallacy of composition is showing some promise. So I went back and I came up with a task. No one asked it. We had myself, we had other people in math education, we had other people going, well, wait a minute, they might be interpreting head, 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 tail, tail as 3 heads and 2 tails. And if it was 3 heads and 2 tails, then we need to reconsider their response. So I said, okay, let me go ask about 3 heads and 2 tails before we start getting ahead of ourselves. So I said, which is less likely, 3 heads and 2 tails, 4 heads and 1 tail, or are they both equally likely? Think of your response. Think of your response to how someone else might respond to this question. And then the weirdest thing happened. I had 63 people that were kind of looking at this question. But I want to talk to you about what this fallacy of composition is. So essentially, you're taking some attributes that are associated with parts of things, and then you're looking at the collective and saying those same attributes will be a part of the whole. And so the example that I like to use is we have bricks, and these bricks are considered the parts, and bricks are really sturdy. A brick is sturdy. So if we were to put a bunch of bricks together, that bunch of bricks should be sturdy. That's an example of the fallacy of composition. You're taking the sturdiness associated with the brick and applying it to the whole, right? It's not necessarily the case. And you can think of an example, or another example, members of an army are strong, so you put all of those individuals together and the army is strong, which is not necessarily the case. Yes?
So, am I misreading it? When it looks like you've taken this issue of a specific order of outcomes out of the question now?
Yes,
Okay.
I have taken it out. I have also done it while the order is still in the question, but that will be, I won't have time to get to that. That's part of the what's next.
You mean
So,
the 3 and 2 versus 4 and 1? They're reading it as if the 3 precedes the 2 and the 4 precedes the 1?
well, I can answer that question as we go through this here.
Okay.
So it's been done in 2 examples, one in the 3 and 2, and I've also done it for sequences as well. So I'll show you this and then we can get back to it if I haven't adequately addressed that there. So, we had a number of participants who responded correctly. Again, I'm always saying normatively correct and normatively incorrect. So they said that 4 heads and 1 tail is less likely than 3 heads and 2 tails, which is true. But the interesting part that happened was the majority of them said these are both equally likely. So again, we have another instance where we have these responses where you can go normatively incorrect, we're done here, that's wrong. Or, again, we're going to take a look at what's happening in these responses. So we're going to look at both of them, because what I found, which was quite interesting, the fallacy of composition showed up, albeit differently, but in both of those types of responses. So Rupert, Robert, and Amber. What they're doing is they're saying this coin is equiprobable. The chances of a head are equal to the chances of a tail. What you've given me is made up of individual coin flips that have that property of heads and tails being equiprobable. So when you put it all together, that should be associated with that as well. So 3 heads and 2 tails versus 4 heads and 1 tail, we're going to have that be the case. The outcome, now they say it differently. The outcome when flipping a coin, the end result, that's that sort of notion of the collective here. Taking that attribute that's associated with each of the coin flips and saying this now applies. So we see this here in that response. And again, just analyzing it through the fallacy of composition, the ratio for the coin is 1 to 1. The event that you're seeing, the building essentially, is made up of these individual coin flips. So that property, like the sturdiness of the bricks put together, the equiprobability should be there as well. It's slightly different for those that responded to the notion of equally likely. Did I explain equally likely for the 3 heads and 2 tails? There is an equal chance that you'll get heads or tails. So there's an equal chance of coming out with that at the end. The equiprobability is associated with the individual coin. Each pattern that is created, again, there's different ways that we're talking about everything being put together, but that property associated with the coin flips, the individual coin flips, gets transferred to the whole, which in this case here is the event. So each time you flip the coin, there's a 50 chance of the coin being heads or tails. Each pattern that is created by flipping the coin, so here we're talking about the whole as well, so then each of those, and again he references the pattern, his whole is going to have that property associated with it. So it's going to be equiprobable. So we're seeing the events, we're seeing the fallacy of composition in normatively correct and normatively incorrect responses for the events. What's next is that there's something that I'm looking at right now where they're showing the fallacy of composition is applying for not events but for sequences. So if we take the original research where you present heads and tails, head, tail, however it is, the fallacy of composition is also accounting for incorrect and correct responses as well. The last thing that we're taking a look at is we are examining some of the other fallacies that are out there. They are showing up in different instances, especially with teachers' responses to counterintuitive probabilistic questions. But the interesting part right now is we're correlating the fallacies to a bunch of the models that exist. These people have these names for things that are happening, but we're taking a look and finding that these are just rebrandings of a number of different logical fallacies that exist. So, interesting strategy. And I'm going to leave you with a question. Now it's your time. We have a comparative analysis here. Which of the following, from that you've heard, which is most likely or least likely to account for these relative likelihood comparisons? Are you a fan of the original heuristics and biases program where we're talking about the representativeness heuristic? Were you interested in some of the notions that were coming out of mathematics education, not presented in as much detail? Or maybe you were a fan of the cognitive psychology research where we started talking about attribute substitution. Or maybe relative likelihood comparison research should be using logical fallacies. So we sort of end with an interesting way of taking a look at it in terms of which one do you think is most or least likely. So that's me. If you want a shameless self-Twitter promotion, I am trying to curate all the information on the internet associated with mathematics and mathematics education. You can follow me at Mathematics. I also microblog a lot of the stuff that I'm tweeting over at Mathematics Education, and hopefully I've left enough time for some questions.